Hello everyone, welcome to IPE 507. So my name is Ogutomo Olasokomi. You can just call me Sky. So today we're going to be treating the topic curve design. So on our curve design, what we are planning to do or what we seek to do is just to represent a curve with a polynomial equation. So under curve design, the two things that we seek to address are number one, which is curve representation, and then the other thing is shape control. Alright. So under this curve design, the oldest method of curve design that we have are the oldest methods of curve design are number one, we have the curve interpolation method, and then we have the curve fit method. So then when you're talking about the curve interpolation method, it means that we are employing an interpolation approach towards getting the polynomial equation to represent the curve. So under this curve interpolation method now, we also have two methods that we can use as an approach. So we can either use the Newton divided difference method, that is under curve interpolation method. So we use the Newton divided difference, or we use the Lagrangian interpolation method. So these are like the basic things that we need to know before we go into the representation of the curve. So just know that under curve design, there are two things we're trying to address: curve representation and shape control. Then the methods that we can approach are is either you use the curve interpolation method, which also has two approaches. So the first one is Newton divided difference approach, and the second is the Lagrangian interpolation method. Then we also have the method of curve fitting, which we are going to discuss furthermore in this tutorial. So let's just go straight to the Newton divided difference method. All right, so talking about the Newton divided difference method. So in this method, we assume an equation for the polynomial representation of the curve. So the equation that we assume is that y, which is equals to p of x, is equals to alpha naught plus alpha 1 into bracket x minus x naught, then plus alpha 2 into bracket x minus x naught, x minus x1, then plus alpha 3 into bracket x minus x naught, x minus x1, x minus x2. Then you just keep on adding until you get to a point which is alpha n minus 1 into bracket x minus x naught, which you're also going to multiply until you get to x minus n minus 2. So this is the equation that we assume for the Newton divided difference method. So now if you assume that x is equals to x naught, so when x is equals to x naught, that is y naught, which is also equal to p of x naught. So anyway you have x in this equation, just replace it with x naught. So if y naught is equal to p of x naught, and that is equal to alpha naught plus alpha 1 into bracket x naught minus x naught, then you have plus alpha 2 into bracket x naught minus x naught, then all this multiplied by x naught minus x1. So you're going to notice a trend that x naught here is minusing x naught, so which means it's going to be 0. So if this particular term in this additive sequence is going to be 0, which means that we can neglect this x1, that means we can neglect the product of x1 into bracket x naught minus x naught. We also find that repeating itself here also, where where alpha 2 is multiplying x minus x naught. So we are always going to have that scenario because x minus x naught always cancel themselves out. So the only place where x naught are not going to cancel out is only in the first term, where we just have alpha naught. So we can conclude that y naught, which is equals to p of x naught is going to be equal to alpha naught. That is the first conclusion based on the assumption of this equation. So the next thing we're also going to consider is this, that where x is equal to x1, that is in each of these terms, replace anywhere you have x, put x1 there. So you're going to be having x naught plus alpha 1 into bracket x1 minus x naught plus alpha 2 into bracket x1 minus x naught also multiplied by x1 minus x1. So you can find something here again that x1 minus x1 are going to cancel themselves out. So which means that this entire term is also going to end up in 0. So we can neglect this. If you go further to the next term, you're also going to find that at a point, even in this product, you're going to find that x1 here minus x1 is going to cancel out. So which means that this entire term, until you get to this x, until you get to alpha n minus 1, is always going to give you 0. So we can make this conclusion now that y1, which is equals to p of x1, is going to be equal to alpha naught plus alpha 1 into bracket x1 minus x naught, because it's only at this term that you're not going to have 0. So you're going to stop here. So if you continue following this trend, you're also going to have that y2, which is also equals to p of x2, is going to be equal to alpha naught plus alpha 1 into bracket alpha 2 minus x naught bracket alpha, okay, I'm going to have alpha 2 minus x naught, then plus alpha 2 into bracket alpha 2 minus x naught also multiplied by x2 minus x1. So usually here you're going to stop that where you're not going to have any 0 in the particular equation. So you're going to stop here. So we can arrive at this conclusion that provided we are following this approach of Newton divided difference, then if you are assuming this equation that y is equal to p of x equals to this entire equation, then if you can substitute your term for where x is equal to x naught, where x is equal to x1, and where x is equal to x2, then you are going to have these formulas. So what we are going to do is that the aim of this is just to find our terms. We are trying to find what our alpha naught is, what our alpha 1 is, what our alpha 2 is, depending on the number of points that are given in the question. So now, in this entire curve design method now, provided that we have a curve, let's say we have this curve, and then curve is something like this, and then we just pick a point, we place different points along this curve. Let's call here point 1, let's call here point 2, point 3, and point 4. Each of these points are going to have a particular coordinate along this graph, because this is just a simple 2D graph in the x and y coordinates. So now, provided at this point they each have a coordinate, which means at this point 1 is going to have a coordinate of x naught comma y naught, because that's our first point. Then our second point is also going to have a coordinate of x1 comma y1. Our third point is also going to have a coordinate of x2 comma y2. Then our fourth point is also going to have a coordinate of x3 comma y3. So with this, we can actually evaluate what our equation is. Remember that the main aim of curve design is that we're trying to represent this curve with a polynomial equation. So if we can know what our coordinates are, that is x naught, x1, x2, x3, y naught, y1, y2, y3, and then we can also find out what our alpha naught, alpha 1, alpha 2, and alpha 3, and probably alpha 4, depending on the equation or number of points are given in the question. Then we can always evaluate and get our polynomial equation that represents this particular curve. We're going to be solving this example now, applying all that I've learned so far. So in this example now, the question states that construct a polynomial to interpolate through the data points given. So data points given are, we have the first point 0, 0, the second point 1, 2, we have the third point 3, 2, and we have the fourth point 6, minus 1. So from here now, what we're just trying to do is that I've been given these data points. So now these data points are assumed to be along the curve that we want to represent with a polynomial equation. So now what we have to do now is to represent this data point, is to represent the curve which has this data point with the polynomial equation. So now the first thing that we're going to do now is to first bring out our points that were given in the question. So solution. So we have the points as follows: 0, 0, then we have 1, 2, then we have 3, 2, and then the last point that we have is 6, minus 1. So now this point, now since it's our origin, we're going to assume that this point is our x naught, y naught, this point, and then this next point is x1, y1, then this is x2, y2, and this is x3, y3. So now what we're going to do next is just to follow what we've been learning so far, which is on Newton divided difference approach. So now the assumption that we know why following the neatly divided difference approach is to apply the formula where y, which is equals to p of x, and is equal to alpha naught plus alpha 1 into bracket x minus x naught, then plus alpha 2 into bracket x minus x naught multiplied by x minus x1, then plus alpha 3 into bracket x minus x naught multiplied by x minus x1 multiplied also by x minus x2. So now the number of terms that we're going to have is solely dependent on the number of points that were given in the question. So now we have just 4 points here. They have point one, point two, point three, point four. So this, it also means that the number of terms we're going to have is also going to be 4. So this is our first term. That is in the additive sequence. We have x naught. Then we also have we have alpha naught rather. Then we have alpha 1 into bracket x minus x naught. Then this is also another term, and this is the fourth term. So that means that we're going to be stopping here because according to the neatly divided difference approach, you can actually get for as many points as possible depending on the number of points that you're considering along the curve. So since we're only giving 4 points, we're also going to consider just only 4 terms in this equation. So the next thing we're going to do is to apply what the formula states. So assume that your x is equal to x naught. So that is where x now is equals to x naught. We know that y naught, which is equals to p of x naught, is going to be equal to alpha naught. That's according to the just by slotting in your values into this equation, you're going to get this. So now, which means that we've already been given y naught from the question already. So from this question, our x naught is 0, our y naught is 0. So which means that here y naught is 0. So automatically we can assume that our alpha naught is equal to 0, since y naught is equal to alpha naught. So the next point we are going to go to find now is to find what our y1 is. Remember that the main aim that while we're going through this process now is to get what our alpha naught is, what our alpha 1 is, what our alpha 2 is, and what our alpha 3 is. Then once we've gotten these values, we just slot them in back into this neatly divided difference equation, and then already gotten the polynomial equation that represents the curve. Alright, so these are the points that we're given. So now we already gotten that our y naught is equal to 0 because y naught is equal to alpha naught. I've already gotten that is equal to 0. So now the next point is that y1, which is equal to p of x1, and that is also equal to alpha naught plus alpha 1 into bracket x1 minus x naught. So then we just start our values that we already know. So we already know y1 from here. So this is our y1 because this is x naught, this is y naught, this is x1, this is y1, this is x2, this is y2, x3, and this is y3. So now from here now we can just put our values. So y1 is equals to 2, so that is 2 equals to, we already gotten that alpha naught is equals to 0, so just start 0 in. So 0 plus, we're trying to get alpha 1 now, so we don't know what alpha 1 is for now. So that's going to be alpha 1, then into bracket, what is our x1? If you come here now, we can say that our x1 is 1. So that's going to be 1, then minus x naught is equal to 0. So we can say that 2, which is equal to, by the time you simplify everything you have, you're going to have x1. So which means that our x1 is equals to 2 from here. So we can say that our alpha 1 rather is equal to 2. So we're going to go to the next one to find our alpha 2, which is equals to alpha naught plus alpha 1 into bracket x2 minus x naught, then multiplied by x2 minus x1, then plus minus x naught, then plus alpha 2 into bracket x2 minus x naught multiplied by x2 minus x1. So I'm going to stop here. So now, as you can already get from our point, our y2 is equal to 2. So 2 is going to be equal to our alpha 0 is equal to 0 plus our alpha 1 is equal to 2. So 2 into bracket. Our x2 from here is giving us 3 minus 0, then plus. So looking for our alpha 2. So alpha 2 is also equal to x2 here is giving us 3 also. So 3 minus 0 multiplied by x2 also is giving us 3 minus, but our x1 now is giving us 1. That's 1. So by the time we simplify this, we're going to get 2 which is equal to 6 plus alpha 2 multiplied by 3 multiplied by 2. So as we find this further, we're going to get that minus 4 is going to be equals to 6 alpha 2. So our alpha 2 is going to be equals to minus 4 over 6. It can be further simplified as minus 2 over 3. So we can say that this implies that alpha 2 is equal to minus 2 over 3. Then we're also going to go further to get what our y3 is because we're given 4 data points. So to get our y3, we're going to say that y3, which is also equals to p of x3, is equals to alpha naught plus alpha 1 into bracket x2 in bracket x3 rather, x3 minus x naught, then plus alpha 2, which is equals to x3 minus x naught, then also multiply by x3 minus x1, then plus alpha 3, which is equals to x3 minus x naught, multiplied by x3 minus x1, multiplied by x3 minus x2. So as usual, as I've been doing so far, we just plotting the values that we already know. So what is our y3? Our y3 is given as minus 1. So which means that minus 1 is going to be equals to 0 plus our alpha 1 is 2. That is 2 into bracket. Our x3 is given as 6. So 6 minus 0. Then plus our alpha 2 is given as, we already found that out to be minus 2 over 3. So we say minus 2 all over 3. That's for x2, then into bracket 6 minus 0. So you can even find that the pattern is repetitive because we're always having this 6 minus 0 because it's the same term that we have here, that we also have here. So going further also, we have 6 minus, what's our x1? Our x1 is given as 1. We have that. Then for the last term, we also have plus x alpha 3 rather, which we are trying to figure out. Then into bracket 6 minus 0, then 6 minus 1, then we have 6 minus 3. So I'm going to leave our point here so that we can still see it. So I'm not going to continue here. So yeah, it means that minus 1 is equal to, simplifying this, I'm going to have, that's going to be 12, then minus 2 over 3 into bracket 6 multiplied by 5, then plus alpha 3 plus alpha 3 into bracket 6 into bracket 5 into bracket 3. So I'm going to have this. So now on further simplifying this, I'm going to have that minus 1. But let me just take this 12 to this place. I'm going to have minus 13. It's going to be equal to minus 2 over 3 times 30 plus alpha 3 bracket 90 multiplied by 90. I'm going to have this. So minus 13, that's going to be minus 10. So minus 20 plus 90. So if I bring this to this other side, I'm going to have that minus, that is minus plus rather. That will be 7 is equals to alpha 3 multiplied by 90. So our alpha 3 is going to be equals to 7 over 90. So this is the implication of this. That we already gotten that our alpha 3 equals to 7 over 90. So now we already found out our value for our alpha naught. We already gotten our alpha 1, we gotten our alpha 2, and also gotten our alpha 3. So what we just do is that since we already know these values, we just slot these values into the equation. That is the Newton divided difference approach. That into the equation. Then you have successfully found out the polynomial equation that represents the curve for the data points that we're given, which are these in the question. So let's just gather our points together and the values that we've already gotten and then put them back into the equation. All right, so these are the points that we've successfully gotten by following the Newton divided difference approach. So what we just want to do now is just to put these values back into that equation, and then that's going to give us our polynomial equation for representing the curve. So now the assumption that we made for, or the formula for Newton divided difference approach is y, which is equals to p of x, that is equals to alpha naught, then plus alpha 1 into bracket x minus x naught, then plus alpha 2, which is equals to x minus x naught multiplied by x minus x1, Then we also have plus alpha 3, which is also equals to x minus x naught plus multiply by x minus x1 multiply by x minus x2. So as we already said already, we are stopping at this term because we have just 4 data points. So slotting in our values in now, we can get that the polynomial equation that represents the curve for those data points given is y, which is equals to p of x equals to our alpha naught is given as 0, so that's going to be 0, then plus our alpha 1 is 2, so that's going to be 2 into bracket x minus what is x naught from this point. We have that our x naught is 0, so put our 0 here minus 0, then go to the next term, that is plus our alpha 2. Alpha 2 is given as minus 2 over 3, so we'll just put minus 2 all over 3 minus 2 all over 3, then multiplied by, that is x minus x naught is 0, multiplied by x minus x1 is given as 1, so 1, then plus the last term given, that is going to be alpha 3, which is 7 over 90, so 7 over 90 into bracket x minus 0, x minus 1, then x minus our x2 now is 3, so x minus 3. So we can actually just say that this is the equation, but we can simplify it further. So on simplifying this further, we're going to get our y is equal to 2x, then minus 2 over 3x into bracket x minus 1, then plus 7 over 90, which is also equals to x multiplied by x minus 1 multiplied by x minus 3. So we can successfully say that we've already gotten the polynomial equation that represents that curve, the curve of which we don't know, but we know the data points that were given. So these data points were placed about the curve. So we don't know if they were evenly placed or not, but we know that these data points were placed about the curve. And since we know data points, we've successfully gotten our equation that represents this curve, which means that from this curve now, if we were to plot a graph using this particular equation, we can get a curve which is the original curve that represents these data points that were given in the question. So that is just all about knitting over the infinite approach. So now we're going to be going into the next step, into the next approach, which is the Lagrangian interpolation method. Using the Lagrangian interpolation method, we're also going to try to solve the previous question, which was solved using the Newton divided difference approach. So now, following the Lagrangian interpolation method, we also have the equation given that's y for y is equal to p L n minus 1 into x. So this can be further simplified into the summation of from I to 0 of n minus 1 of L I to x of n minus 1, then multiplied by yi. So this is the Lagrangian formula. This is for getting it. So what does our n represent here? So our n is just the number of points that we're given. So n is the number of points given. So according to the Lagrangian interpolation method, it means that if you can get this equation, that is the equation that y is equal to p subscript l raised to the power of n minus 1, which is a function of x, which is equal to the summation of li, which is also a function of x raised to the power of n minus 1 multiplied by y subscript I, which ranges from I to 0 to n minus 1. So if you can get this, you can get the summation of these data points already. So which means that we can get the same equation that represents that same curve, but using a different approach. So now we're going to be applying this equation now to the previous question that was solved. So now you can remember that from that question which we applied the Newton divided difference approach, the points that were given are, the first point was 0, 0, the next point was 1, 2, then the third point was 3, 2, and the fourth point was 6, minus 1. So now we can get now that if our n is equal to the number of points, which means that from this question now we have first point, second point, third point, and these are our fourth point. So if our n is equal to 4, then our n minus 1 is obviously going to be equal to 3. So now we can further simplify this equation to fit this question that we are solving now. So now this means that according to this question now, our y is going to be equal to p subscript l n minus 1, that is from the question above, which is a function of s, which is also equal to the summation from I equals to 0 to n minus 1 of L subscript I n minus 1, which is a function of x and yi. So very good since our n minus 1 is equal to 3. So which means that y now, simplifying further, is going to be equal to pl to the third power, which is a function of x, as is equals to the summation of I from 0 to 3 and the Lagrangian equation, which is also to the third power of x, then y subscript I. So since we've already gotten this already, so the next thing we're going to do is that what does our li, which is a function of x, what does it represent? So we're going to try to simplify this one further into this question. So doing that now, we're going to get this. We're going to get at our y, which is equals to pl of 3 now, which is a function of x, as is also equal to the summation of li of x to the third power and yi. So this is equal to, if you just, what I just doing here is that this is ranging from 0 to 3. So and this is a summation as usual, which means that our I is ranging from 0 to 3, which means that we're going to have a point where I is 0. We're also going to have another point where I is equal to 1. We're also going to have a point where I is equal to 2 and where I is equal to 3. So let us now spread this out. So doing that, we're going to have L naught. We're going to have L naught, which is raised to the third power of x, then y naught, then plus L1, which is also a function of x raised to the third power, then y1, then plus L2 raised to the third power, which is also a function of x, then y2. Then lastly, we're going to have the last term, which is L3 raised to the third power, which is also a function of x, then multiplied by y3. So this is what we're going to have. But then the question is still kind of vague, because we still need to get what our L naught is, what our L1 is, what our L2 is, what our L3 is. So to get that, we're going to also simplify this further. So what that represents is this. So let me just erase this. And I'm going to leave our number of points. I also leave the question here. So what I erased here is also here already. So now what I'm going to do is this. What about L naught raised to the power of 3, which is also a function of x, multiplied by y naught? What this means is this. We can write this as x1 minus x naught multiplied by x2 minus x naught multiplied by x3 minus x naught multiplied by y naught, which is what we have here. Then on this top, we're going to have x minus x naught, x minus x naught. Let's write this. So our L naught raised to the power of 3 of x is equal to this. It's going to be equal to x naught minus x1, x naught minus x2, x naught minus x3 multiplied by y naught. Then as our numerator, we're going to be having x minus x1, x minus x2, x minus x3. So that is what this term represents. That is without even putting this y naught. So this singular term here, this is what it represents. So if you want to put this back into this equation, of course, you are going to have to multiply it by y naught. But this is what it represents. Then also you follow the same pattern, and you also do for L1 raised to the third power, the function of x. So this is going to give us this. I'm going to have x minus x naught, x minus x2, x minus x3. Then beneath, we're going to have x1 minus x naught, x1 minus x2, x1 minus x3. We're going to have this. Then also for the second and the third, we're also going to do the same thing. So we can notice the pattern that whatever term we're picking, the x naught here, you can see that it's always x minus x1, x minus x2, x minus x3. Here also, we're also minusing x naught minus x1, x naught minus x2, x naught minus x3. So whatever if we are picking L naught, which means that L naught is also subtracting on the denominator, you can see that X naught. And since X naught cannot subtract itself, then we're going to pick the other terms, which is X1 minus X1, X naught minus X2, X1 minus X3. And then the same pattern we have beneath is also what we're going to have above. You cannot have X naught here. So it's only X that's going to be subtracting from the other terms, provided that we're picking this L naught. And the same pattern is also what we applied here. So you cannot follow the same pattern for the rest. So let's just slot in our equations into the Lagrangian interpolation method. So having that, we can say that simplifying this equation, that is y, which is equal to summation from I to 0 to 3, that is L I 3x yi. So all this is going to be equal to what we have here. So for the first term, we have x minus x1, x minus x2, x minus x3 all over x naught minus x1, x naught minus x2, x naught minus x3. So this is going to be multiplied by y naught. Then the next term that we have, say plus, the next term we're going to have is going to be x minus x naught, x minus x2, x minus x3. So this all over x1 minus x naught, x1 minus x2, x1 minus x3. So this is multiplied by y1. So we're also going to plus this with the term for y2 and y3. So to add this on top now, we're going to be having at our third term now is going to be x minus x naught, x minus x1, then x minus x3. Remember that whatever term you are picking, you cannot have the term of x inside this equation. So over x2 minus x naught, x2 minus x1, x2 minus x3, then multiply by y2, then plus, you're going to have the last one, x minus x naught, x minus x1, x minus x2, then all over x3 minus x naught, x3 minus x1, x3 minus x2. Then this is going to be multiplied by y3. So this equation is just as simple as it is. We already know our data points already. We know what our x naught is, we know what our x1 is, we know what our y1 is, we know what our x1 is, we know what our x2 is, we know what our y3 is. We also know what our we already know the points that were given already according to the point. So we'll just slot in those points inside this equation. So if we were to slot this point inside this equation now, so because I'm not going to change the values here. So our points that we're given are, we have 0, 0, we have 1, 2, we have 3, 2, we have 6, minus 1. So these are the 4 points that we have. So this is our x naught, as remember, this is our y naught. So now if you come here now for this first term now, our x1 now is given as 1. So we just change this to 1. But of course, we are solving it on paper. We have to write the equation again afresh. So our x1 now is going to be equal to 1. Then our x2, which was given from here, is going to be equal to 3. Change this to 3. Our x3, which was given, is going to be 6. So we change this to 6. So we change this to 6. Then we'll come also beneath. What's our x0? Our x0 is 0. So this is going to be 0 minus 1. This is going to be 0 minus 3. 0 minus 3. Here we're going to be having 0 minus 6. Then what's our y naught? Our y naught is also 0. So which means that the entire term here will just cancel out. Alright, so coming back here also to the second term that we have, our x naught is given as 0. So we're going to have 0 here. Our x2 is given as 3. We have 3 here. Our x3 is given as 6. Then we'll put our 6 here. Then our x1 now is given as 1. So we're going to be having 1 minus 0. So we can see that the pattern that I was talking about previously, that is, when we have minus 0 here, minus 3 here, minus 6 here, we're also going to have the same beneath. So we're going to do 1 minus 0. We're also going to have 1 minus 3. We're also going to have 1 minus 6. Because we are subtracting from the same term, both in the numerator and also the denominator. So our y1, which is also given from here, which is 2. So we're going to multiply this by 2. So now going to the third term now, our x0 is given as 0. So we just change this to 0. Our x1 is given as 1. We're going to have 1 here. Our x3 is giving us 6. We're going to have 6 here. Then our x2 now is giving us 3. So we're going to have 3 minus 0. We're going to have 3 minus 1 here. And we're also going to have 6. We're going to be 6. We're going to have 3 minus. We're also going to have 3 minus 6 here. 5 our y2 is giving us 2. To multiply by 2. Then to the last term, so is our x naught here is 0. Our x1 is 1. Our x2 is 3. So our x3 is giving us 6. So we're going to have 6 minus 0. You are going to have 6 minus 1. You are going to have 6 minus 3. Then all multiplied by minus 1. So multiply it by minus 1. So on simplifying this further, once you simplify this further, then you've already gotten your question already. Because everything here is equal to y, which is also equal to PL of n minus 1, which is a function of x. So let's just combine the equation together and simplify it. And let us see what we're going to get as our answer. Alright, so this is what we've been able to come to conclusion at. So now to further simplify this now, we're going to have that our y is going to be equal to x minus 1 is still going to remain x minus 1. So we can leave it as x minus 1. So we're going to have x minus 1, then multiplied by x minus 3. Then we can also multiply it by x minus 6. Then beneath now, we're going to have that 0 minus 1 is going to be minus 1. 0 minus 3 is going to be minus 3. 0 minus 6 is also going to be minus 6. So we're going to be having minus 1 multiplying minus 3 multiplying minus 6. So by the time you multiply this, we're going to be having minus 18 beneath. So now you go to the next one now. That is this second term. We're going to have plus. So this is also going to still be x. So x minus 0 now is going to give us x. So we can write x there. So x multiplied by x minus 3 multiplied by x minus 6. So all over 1 minus 0 is going to be 1. So 1 times 1 minus 3 is minus 2. Then 1 minus 6 is going to give us minus 5. Then all this. Also, don't forget that all this is multiplied by 0. So we're going to be having times 0 here. So which means that this entire term is going to tend to 0. Because 0 is multiplying it. So which means that you might not actually even need this term in the final collation of the answer. But just to follow it step by step, we might need to include it there. So in this second term now, we can see that this one is multiplying, it's being multiplied by 2. So we're going to write multiply by 2 there. So by the time you solve or simplify this that you have, you're going to have 10. So you're going to have 10 here. Then go to the next term. You're going to have plus. So x minus 0 is also going to give us x. So I'm going to have x, then x minus 1, then x minus 6. Then beneath, we're going to be having 3 minus 0 is still going to be 3. 3 minus 1 is going to give us 2. So 3 times 2, that is 6. Then we're also going to have 3 minus 6, that is minus 3. So 6 times minus 3. So yeah, we're going to be having 3 multiplied by 2 multiplied by minus 3. Then all this is multiplied by 2. So then by the time you simplify this further, we're going to do 3 times 6 times minus 3. You're going to be having minus 27. So this is going to be 3 times 2, that's going to be 6. So 6 times 3, that's also going to be 18. So I'm going to have minus 18 here too. So now go to the last term now. So this is the last term. So I'm going to have plus, that's going to be x, then multiplied by x minus 1, multiplied by x minus 3. Then all this is going to be over 6 times 6 minus 1, that's 5. Then multiplied by 3. So that's going to be 6 times 5 times 3. So all this is multiplied by minus 1. So to remove this minus 1, we cannot change the sign in front of this to plus. So we might not have to include this any longer. So minus. So we've already gotten the answer also. We cannot further simplify this. Instead of 2 over 10, we cannot leave it as also 5. So we can say it's going to be over 5. Yeah, so instead of 2 over 18, we can leave it as minus 9. Then here, By the time we simplify this further, that is 6 times 5, that is 30 times 3, that is 90. So we're going to have 90 here. So this is going to be the final answer. So, but if you want to further simplify this and try to expand this x minus 3 so it can look like the need interval difference, you can also go ahead with that. But you can also conclude the answer as this. So your answer should look something like this. So since this term is going to tend to 0, you can as well just omit the term. So omitting that first term, the final answer is going to be y, which is going to be equal to x into bracket x minus 3, x minus 6 over 5, then plus x into bracket x minus 1, x minus 6 over 9, then all this minus x into bracket x minus 1, x minus 3 over 90. So here you have it. This is going to be your equation for the curve. So this is a polynomial equation. So how do you know that it's a polynomial equation? By the time you begin to expand it, you're going to have a quadratic, and you're also going to have a power raised to the power of 3 rather. So we can see that this is the polynomial equation that represents this curve, given that we have those points that we have. So if you want to further, because normally by default the answer you get using the Lagrangian interpolation method should also be the same with the answer you get using the Newton divided approach. So you can leave your answer as this. You can also further simplify your answer to get the same answer you got while using the Newton divided difference approach. But this answer is also fine, and you can leave it like this. So this is our equation, which is y equals to p of x that represents this. So I hope that you've been able to understand all that you've learned so far. So you can also have a scenario whereby in the question that you asked to find, you already asked to find the curve that represents those given data points. But then you can also be asked to find that, okay, if a particular point here was perturbed. So what they basically mean by perturbed is that if you change the point, so because that's what perturbed means, you can check the dictionary for that. So which means that if you have to change any given point there to another point, then they say that if those points were to be perturbed, what is going to be your new polynomial equation that represent that curve? All you just have to do is change that particular point, then solve it from the beginning again. As simple as that. So here's an example of that. So it says that if point 3, that is from the previous question, if point 3, so what is point 3? Point 3 is our point 3 comma 2. So if this point was perturbed, so if point 3 is perturbed, that is, it is changed. So that's what it means. It means that that is changed to a new point given as 1.5 comma 4. So if our point was perturbed and changed to this, so initially now we know that our this is what our curve look like. If we are to just draw a rough sketch of what the graph is going to look like, so we have our first point 0 comma 0. Let's say that it was started from the origin 0 comma 0. Let me first start our point. So we have 0 comma 0. We have the next point. That is from the previous question now. We have 1 comma 2. Then we have 3 comma 2, and we have 6 comma minus 1. So this was from the previous point. So let us now try to like plot a rough sketch of the graph that we're going to result from this. So let's say this is our y-axis as usual. This is our x-axis. So the first point now is 0 comma 0. This is going to be the origin, the point. So the next point is that when x is 1 and y is 2. So let us say that this is our 0. This is 1, 2, 3, 4, 5, then 6. Let me further 4, 5, 6. So this remains our x, and then our y extends to minus 1. So let me extend this also to minus 1. So minus 1, so 0. Then we have 1. Then we have 2. Then our y maxes out at 3. So now let's say that our first point is 0 comma 0. So it's given at this point. Then our next point is when x is 1, y is 2. So somewhere here. Then our next point is when x is 3, y is 2. So somewhere here. Then our last point I was given was when x is 6, y is minus 1. That is somewhere below here. So if we were to draw the curve of this, it's going to be something like, it's going to look something like this. This is what the curve is going to look like if you were to draw it. So remember I said that these curves now, these points that we're given now, it was not there in the question whether it was evenly spaced about the curve or it was not evenly spaced. But one thing that we know for sure is that the points are along the curve. So and if we know about three or more points, then we can always get the equation that represent that curve. So now we can see clearly that these points are not evenly spaced, but that's not the matter now. So the question now is saying that if point 3 now is to be perturbed, that is, if it was changed to another point, 1.5 comma 4. So which means that the curve is still going to remain the same. But this point 3, that's our third point, if it was changed to when x is 1.5 and our y is 4. So let's say y is 4 here and x is 1.5. So 1.5 will be about here and y is 4. So if it's our third point inside of this, it means that our curve now will now be something like this. That will still pass through this point 2, go to point, this new third point, then curve down and come back here. So now this is going to be the perturbed point, the perturbed curve. So our perturbed curve is going to be this, and this is going to be the normal curve that was given that was in the question. So this is our original curve. So this is just like explaining what that question is just saying. So it means that if you are perturbing this point, you are changing this point to this place. What is going to be the new equation that represents this curve? All you just have to do is change the point in the question and solve everything again. Which means that your new x2 comma y2 is going to be 3 comma 2. Because originally now, no, our new x2 comma y2 rather is going to be 1.5 comma 4. Because originally now, when the question was given and data points were also given along with the question, it was 3 comma 2. When this point become perturbed, it becomes changed to 1.5 comma 4. Then you solve from the beginning again. So whether you're using the Newton divided difference approach or you're using the Lagrangian interpolation approach, it does not matter. The main thing is that you are changing your third point now to the new point that was perturbed to, and then following the same procedures and the steps that I've been using along the way to solve the question. Then you can always get your answer for the polynomial equation that represents the curve. Yeah.